Hey guys, my name is Basit, and today we're gonna solve a task on Codelity. I was trying to solve this, and I thought I should share this with you guys. Okay, so let's start the test. So that's our test. If you're gonna start it, so we got 120 minutes to solve this task, but we'll try to solve it in minimum amount of time. So uh, yeah, you can see we got 120 minutes, like 2 hours. You can select any programming language uh, you are expert in or you are good in to solve the problem. I'm good in a JavaScript, so that's why I selected JavaScript. So we got a solution function that would be our main function where we're gonna write the code. Okay, so let's read the description. So it's a binary gap, the name of the problem of the task. It's called a binary gap within a positive integer and is any maximal sequence of consecutive zeros that is surrounded by ones at both ends in the binary representation of n. Okay, do you understand? Let's see the example. For example, number 9 has binary representation of 1001 and contains a binary gap of two lengths. We got two zeros in between two ones, like the boundary. The number 529 has binary representation of this, where we get the gap, two gaps. One is the length of 4 and the second is the length of 3. Why we got 4 zeros here and we got 3 zeros here. The number 20 has binary representation of this, where we only have gap of length 1 because in between these two ones we have only 1 0 and the other end is opened. Now we have 15 is binary representation of this. Here we don't have any gap. So the number 32 has binary representation of this, and obviously we don't have any gap here as well. Okay, so that would be our function. We're going to say then given a positive number, integer n returns the length of its longest binary gap. The function should return 0 if n doesn't contain a binary gap. Okay, so for example, we have this number 1041, a decimal number we have. The function should return 5. Why? Because n has binary representation of this, n is at so its longest binary gap is length 5. Here we got, you can see we got two binary gap. This is 1 with a length of 4. I mean, we got 5 zeros in between these two number ones. And here we got another gap with a length of 3, but the longest length is 5. So we're going to return 5 if we pass like 1041 in the function. And the same way, if the number is 32, we're going to return 0 because if you see the binary representation, we don't have any ending 1, so that's why we can't count zeros in between two ones because we don't have any ending 1. We only have 1 in the start. Thus no binary gaps. So write an efficient algorithm for the following assumptions. N is an integer within the range, that's the range. Okay, now let's start the application now. I'm not sure if it is looking good, so I'm gonna zoom in a bit so that we can see it properly. All right, now you see here. So what how we're gonna solve it? So let me write some comments here. So we're gonna solve it step by step for sure. First of all, we will have any number, and to move forward, first of all, we need to convert any number that we get here into the binary number, because we'll be getting only decimal number, so we have to convert it into binary representation. Okay, so that would be our step first. So we're gonna say convert into binary. Okay, now for that we can write this code here, but I'm gonna write another standalone function for this functionality. So I'm gonna say function decimal to binary. Okay, here I'm going to pass the number, the exact number that we're going to get. Okay, now here binary representation, I'm going to put it in the array. I'll say binary array equal to an empty array initialize. We initialize with an empty array, and then here we're going to say let remainder equal to null initially. Okay, so how we convert decimal into, there are many ways. We always do it like how we convert decimal into binary. We keep dividing the number by 2 and getting the remainder unless we get the last number equal to 1. Okay, number that we get by dividing it equal to 1. Okay, so how I'm going to do it, we're going to use a loop, we call it while loop, and we will check that it loops should run unless the number that we get is not equal to 1. Okay, so when the number is equal to 1, we will exit out this loop. Okay, so first of all, we're going to get the remainder. I'm going to say n divided by 2. With this sign, we get the remainder. Okay, so we will get the remainder here, and then whatever remainder we will have, we're going to push that remainder in our binary array, and then we're going to say now divide n by 2 again, and then put the value in n again, because that is our exact incrementer or decrementer. The value will be checked by this n. But the problem with this approach is that, you know, if we divide with that way, we will have the odd numbers, so we can get like floating points number that we don't want to get, because at the end we want to check if we have number 1 at the end. So if we get floating point number, we will not be able to do it. So to solve this problem, we have a function in JavaScript. We call that function truncate, okay, or trunc as shortcut. So, and we're gonna pass that, and with this we will get the rounded number. The floating point or the decimal part will be removed automatically. Okay, now we will do this in the loop. When we are out of the loop, when the loop is ended, when our number n is equal to 1, but you know that we also need to add that number 1 when n is equal to 1, when I also need to add that number into our binary array. How? Yes, whatever we get, we're gonna push that into binary array, and then we also need to reverse the binary array. If you remember, we do it in school times, that when we convert decimal number to binary number, we keep dividing it by 2, and then the binary representation we count from the bottom. Okay, so that's why I'm going to reverse it. Now we have this array, and I'm going to return this array, then binary array. Okay, with this function we will convert any number, any decimal number to binary. Okay, now we got this function. Now we will write our main function. Okay, so here how we're going to solve this, we need to get the maximum. We need to get the length of the gap which has the maximum length. Length of the gap which is the longest gap in between two binary number ones. Okay. Now to solve this issue, first of all, we converted it into binary, and then we're gonna say the second step would be to count the gaps. Okay, so to do that, what we're gonna do, we're gonna create an array here, gaps and empty, because we can have more than one gaps in one binary number representation. Okay, then we will declare another variable bits what we're gonna do with this, we will use this function that we defined right now, and okay, we'll convert this number into binary representation and put it in variable called bits, and then we also declare a variable counter just to count the gaps. Okay, now we have this counter. Here we're gonna run our for loop, simple for loop. Let's say let I equal to, we will not start from 0, we will start from 1, I mean the second digit, because we want to know that if that digit is 1 or 0, because by default the first digit is always 1 in binary representation. Okay, so we're gonna start from the first element, and then we will check it until the last element with this condition I less than bits dot length. Bits is an array, we just get it here with the function that we defined here. Okay, now I'm gonna say we're gonna check if bits of I is equal to 0. Okay, if it is equal to 0, it means we're gonna increment the counter, because I mean, that's how we increase the length of a single gap. Okay, and if it is not equal to 0, like I'm gonna check if it is something else, you can either check it or put it in else. You can say if it is not equal to 0, it means it's 1, then we're gonna say gaps dot push that counter, because when we have number 1, it means the first gap is added. So then we're gonna push that counter into our gaps array, and then we will restart the counter with 0, because now we will count the next gap if we have the next gap. Okay, that's how we're gonna count the gaps. And when our loop is ended at the bottom, when the loop is ended, we're gonna check if we don't have any gaps, it means there's no zeros in between two ones in the binary representation. We're gonna check it like that, then we will return 0, because that's what is described. You can see here has binary representation, 32 has binary representation of this and has no binary gaps, so we're gonna return 0. Here you can check number 32 function should return 0, because n has binary representation of this and there's no binary gaps. So if we have no binary gaps, we're gonna return 0. And in the other, like if we have binary gaps, then we're gonna return okay, now we have to return the maximum number in the gaps array, because we will have more than one gap. If we have more than one gap, how are we going to get the maximum number? So there's a function in JavaScript also, it's called math.max, that gives you the maximum number in the array, and you have to destruct the array like this. Okay, you can put it in different variables, but that's the best and optimal way. So we're going to destruct this gaps array, and that's how we're going to get the maximum number. Okay, so let's test the task that we did. All right, see, all the tests are passed. So let's submit it and see our score. Session ended. Trying to calculate. Yeah, we can see. Yeah, we got 100% as the score. Yeah, so I'll be solving other tasks. I'm doing it, and then I'll be sharing with you guys. Thank you.